Thanks a lot, Lulu. And so, hi everyone. Good evening, probably, I would say. So, I will just share my screen. Give me a second. Resharing it again. Sorry for the technical problems. All right, let's see. Hope you guys can see the screen. Right. Just put a thumbs up if you guys can see the screen. Cool. Yes, so let's get started with this. All right. So, again, hi everyone. Good evening. And today we are actually going to talk about decoding the magic of event loop. So obviously, like you all know, like JavaScript is quite a popular language these days, and there is a lot of concepts that we need to understand. And also, like it almost like every month or every week, JavaScript will always come up with some new frameworks, libraries, or even some tools. But the thing is, like more than these tools and things, it's always good to have the core understanding of how the language itself works and so on. So in order to understand the language itself, there is a lot of things that we need to cover, like with its hoisting, lexical scoping, prototypical inheritance. There are plenty of core concepts that we need to understand. So in this session, we will be particularly focusing on event loop, which is kind of like how JavaScript execute things and so on. So yeah, let's get started with this. So before actually before actually start to explain about event loop, I think it's always good to have some understanding about the JavaScript runtime, because event loop is itself is a part of JavaScript runtime. So there are JavaScript runtime is nothing but that a piece of code or a program that executes JavaScript. So your browsers that do understand JavaScript and execute JavaScript. So all your browsers have this JavaScript runtimes. And also another popular JavaScript runtime option is Node.js, which is a server-side way to write JavaScript programs, and Dino and Bun are like some other alternatives. And there are JavaScript runtimes are there in these are like some of the most popular ones, but there are some more there are quite popular runtimes in IoT space also. So there are plenty of other runtimes also out there. Right. So when we talk about JavaScript runtime components, so this is like sort of the basic view or a very, very, very high level um, runtime overview. So basically, we have different components in this. JavaScript engine is obviously the more of the core component in this JavaScript runtime. And when we talk about JavaScript runtime, engine, it also have two important components called heap and call stack. And also we have something called web APIs, callback queues, and the main topic of today, which is event loop. So something that I noticed when doing interviews is like when we ask to explain event loop, people sometimes come up with this entire runtime. So basically, event loop is not equal to the runtime. Event loop is just a component in the JavaScript runtime. So yeah, let's dive a little bit deep into each of these components. So starting with the JavaScript engine, obviously JavaScript engine is actually the most core component in the JavaScript runtime. So JavaScript engine, what it does is basically get your code, interprets it, compiles it, and executes it. That's what it actually does. So basically, it has different steps like activities, like parsing. Parsing is like taking your JavaScript code and converting it to an intermediary form called AST or abstract syntax tree. And then there are compilers, which actually compiles your code into a machine code. And we have interpreters, which executes your code, compiles and execute your code. And also, every JavaScript engine has some optimization mechanism built in. For example, like uh, V8, which is the most popular JavaScript engine, that does have something called a JIT compiler in it. So JIT compilation is like just-in-time compilation, which means like it just compiles and execute on the go. So it's kind of opposite to AOT, which is ahead of a time compilation. But what just the benefit of JIT compilation is like that. Uh, it executes and it optimizes code on the go. So when executing the program, it actually do understand like um, what are the most used code, what are the least frequently used code, and it actually find some dead code elimination. So it optimize your code and make a performance boost after your execution. So that's also built into JavaScript engine. And finally, we have garbage collection also. So when you write a program, you always declare variables and so on. So there has to be a mechanism which has to clear those created storages. So garbage collector is actually the tool which does that job. And some examples for JavaScript engine is obviously the most popular JavaScript engine is V8, which is used in Chrome browsers or Chromium-based browsers, and also in Node runtime. And other than V8, Firefox's JavaScript engine is SpiderMonkey. Chakra is used in older Internet Explorers. JavaScript core is actually the JavaScript engine used in Safari. Yes. And like I mentioned before, JavaScript engine does have two other important components. One is heap and the other one is call stack. So when we talk about call stack is actually a data structure. Like the name suggests, it's a stack. So obviously, according to the data structure algorithm chapter, you might notice like stacks follow a LIFO principle, which is last in first out principle, right? So uh, what stack call stack does is it will actually keep all the execution context. I will come to this execution context in a short bit, but execution context is like so when you start your JavaScript application, it always will create a execution context called a global execution context. And whenever you invoke a new function, so it will create a function specific execution context and put on top of the call stack. So basically, it's like stack of all the execution context. So yeah, that's the main purpose of call stack, just to keep all the execution context and maintaining the LIFO principle in it. And then we have a heap. Heap is like is the place where objects, references, everything is stored in JavaScript. So obviously, like I mentioned before, garbage collector comes in handy when it comes to cleaning up these storages and keeping memory leak free. So basically, for garbage collection, there are quite a few algorithms out there, like least frequently used ones, mark and sweep. So basically, we are not going too deep into these topics because it's not we thought to cover in this session, but maybe in a future session. Right, and finally, a little bit about execution context, which I mentioned a little while ago when discussing about call stack. So execution context is have two components. One is memory, and the other one is core component. So basically, core code is like uh, basically the instructions, whereas the memory is like the placeholders or the variables get stored there. So these are execution context. So we obviously have always will have the global execution context, and with each function execution, it will create its own execution context. And yeah, that's how JavaScript actually maintains. Right. So we discuss about JavaScript engine, call stack, and heap. The next thing when it comes to JavaScript runtime and environment components is web APIs. So when you are using fetch or set timeout, you might think it's part of JavaScript, the language, but in reality, those are not really part of the language itself. Uh, these are something that whoever the runtime provider has to build on. So basically, when you are using fetch, it's not really part of the language. It's actually implemented by the browser. So in the case of Node build, whoever builds Node.js has to build fetch for us. So it's something that something that help JavaScript, or it powers JavaScript. It's sort of a toolbox for JavaScript actually. So we have tons of different web APIs. Fetch, XML HTTP request is actually earlier known as Ajax. DOM, WebSocket, WebRTC, all these are different web APIs. These are like popular ones, service workers, and these are like popular ones. But other than this, there is WebGL, WebAudio. Probably you might have used geolocation-based web APIs previously. So all these are like not part of language, but these are like really important for our JavaScript program to run. We use them, but it's not part of the language. It's not part of the core language. So that's why we sometimes say like, okay, this the newer browser supports, older browsers doesn't support, because like older browsers might not have these web APIs implemented. New browsers will have this implementation. That's why we prefer some browsers over some other browsers, saying that it's not supported because they don't have the web API support. Right. And another thing when it comes to this components is callback queue. So if we ask like what are the characteristics of JavaScript, people generally will come up and say like it's single threaded, non-blocking, and so on, right? So what is this non-blocking? Non-blocking means in JavaScript we can have synchronous code and asynchronous code. So for example, just think you have a JavaScript program and it runs code line by line, okay, and it has some sort of API call or a file read. Let's say that takes a lot of time. Okay, you have a function and in middle you have some sort of a API call or something like that, but you are not sure about when it will return, and it is obviously a time consuming thing, right? So if your program is waiting for these kind of time consuming event, your program will take a lot of time to execute, right? So obviously you might notice like JavaScript is single threaded, so they don't support the multi-thread where we can actually put these kind of time consuming thing to a different worker thread, and we can, of course, obviously now we have support, but just think JavaScript as a language, it's single threaded, right? So in order to achieve this fast the thing is JavaScript is very well known for its IO operation. In order to achieve this high performance, it needs to have some other alternative to threads to support concurrency, right? So that is actually made possible because of this callback queues. So what happens is when you execute your JavaScript code, when it found these kind of asynchronous code, it actually puts them into a callback queue and continue with the execution to execute the other synchronous things, right? So because of this, we are not blocking. That means like this, your code is not blocked by these kind of time consuming asynchronous functions. It will just continue its execution. So soon as it's done with that, it will just pick the things from callback queue and execute later. So that's how JavaScript achieves this concurrency. But yeah, we will dive deep into callback queue and event loop in a short while. Right. And finally, event loop. Event loop is actually it's like a controller or a coordinator. So we have call stack, we have event queue, we have web APIs, and so many things, right? But event loop is a continuous loop that runs over different phases. So in each phase, it executes certain things. We will dive deep into those things in a short while, but for now, what it does is it will check call stack, frees up it, and then it checks the queue. If the call stack is free, it picks up the callback from queue and put it into call stack. So it actually take care of the execution of your code. So basically, it's more like a traffic police, like how to it routes the things. All right. All right, so I think that's enough of theory. Of course, we have some more slides, but for now, it's let's stop there. It's for now, and right now, let's play a little game. I think it's better if we keep this somewhat interactive, so that at least in a way interactive. So let's play a game. So what you have to do is you have to guess the output of some programs. It's nothing but a bunch of console logs, not really complicated logic or anything. Bunch of console logs. You have to guess the output of these, and then we can actually check how. Yeah. So I will stop sharing. I will reshare my screen again. Mm, Just let me know if you guys can see the screen. Yes. You guys can see the screen, right? All right, cool. Okay, let's start with simple. Let's start simple. Okay, so I have a function. I will give you guys like 10 seconds because it's a simple one. So can you guys guess the output of this? You guys can actually, yeah, you guys can type the answers in the chat. So your time starts now. Uh, I couldn't see any answers yet. Um, okay, you can't see the code. Okay, sorry. Is it same still? Okay. Bit really strange. I'm not sure. Okay, anyway, I will give you another 10 seconds. Just guess the output. A, B, C, D. Okay. All right. Cool. Okay, let's try it. See. Yes, it's A, B, C, D. Yes, correct. Let's go to the second question. Okay, now this is a little bit tricky. Again, I will give you another 10 seconds. You guys can guess the output. You guys can see the second screen also, right? Okay, ACB, ACB, ACB. Yes, perfect. It is ACB. Obviously, we have console log A, and we have a timeout which takes 1 second. Non-blocking behavior comes in handy here. So it will go to line number C3, line number 7, and execute C. And again, back to this. After 1 second, it will print that. Cool. Now comes the third question. Let's see. What is the output now? Is it same or different? Cool. Let's see. It's same, right? It's ACB. So yeah, I mean, some people might have thought like could be ABC because the set timeout has 0 seconds, so it should immediately execute, right? So this is where event loop comes into picture. Okay, again, I will reshare it to the presentation. Sorry guys, I have to go back and forth to share the screen. Hope you guys will bear with me. Can you guys see the screen again, the presentation again? Yes, cool. Okay, I hope this is the function. So as you guys can see, like we have a console, we have a queue, and we have a web API or the node API, and also we have call stack and the code, right? So let's see how the execution goes. As soon as your program loads, it will obviously create the GEC means global execution context, right? So obviously it will push that to the call stack. And when it comes to console log, console itself is a web API, but log is it's async sync. Anyway, it's you can consider it like a synchronous operation for now. Yeah, I mean, this green color one is not a completely new execution context. All the execution according to these diagrams, all the execution context will look like in blue color. So this green color A is just the statement. I'm just there to show like it's executing. So don't think like these green color boxes are different execution contexts. It's just the statement itself. So it will come to console log A. It locks it into the console. Go to set timeout B. The thing is, even though okay, there is a slight issue like this should be 0, but yeah, anyway. Yeah, but the thing is, the set timeout. This is actually like even though it's 0 seconds, it is not. It is asynchronous, right? So what it does is it will not immediately execute things because JavaScript always gives priority to synchronous code. So what it does, set timeout internally use something called timer API in the web APIs. So it goes to that timer API. So it will go there, and instead of blocking, it will go back to C and locks console C, right? And then only it will come to here. So what happens here is, so once web API is done with its timer thingy, it will actually push the callback, which is the function inside this, the callback to the queue, callback queue. So since we don't have anything left in the call stack, if there is something in the call stack, this will never be executed. Since this is empty, other than the execution context, a global execution context, it will just take the callback function, which is printing console log B, and prints it. Yeah, then only the control will go here and prints it. So that is what is happening behind the scenes. And once it's done with the execution context, it will clear everything and keep the call stack free. Right? I hope that makes sense. And I will just reshare the screen again to code. Let me reshare the code again. Let me know if you guys can see the code. Yes. All right. Okay, now let's jump into question number 4. All right. So here, again, this is a little bit tricky. So I will give you like 15 seconds to guess the answer. Just put anything that comes to your mind. It doesn't have to be correct. ADBC, 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 ADBC. Yes, it's almost like everyone saying ADBC. Let's see. It's ADCB, not ADBC. Yeah, obviously, I mean, if you look at this, okay, console log A is fine. It prints immediately. Set timeout, okay, it's asynchronous function, so it will not execute immediately. Again, promise all, resolve is also won't execute immediately. And then because like both are asynchronous functions, and when it comes to console log D, it's a synchronous function, so it executes immediately. So both this promise resolve resolves immediately, set timeout 0 executes immediately, right? Both are like near 0 seconds, but why promise over set timeout even though set timeout comes in first, right? In order to understand, again, bear with me guys, I have to share the screen to the presentation again. Right. Another thumbs up if you guys can see the screen. All right. I hope this is the function, right? Yes, this is the code. All right, let's start. Okay, the global execution context will be loaded to the call stack. Okay, there is a synchronous operation which is logging console log A. It will be printed, and then it will move to set timeout, which is printing B, and it's a asynchronous function. So it will go to the callback queue, right? It will go to the timer API, and then obviously it will go to the callback queue. And then here, so the thing is, when you take JavaScript as the language, there are different types of asynchronous operation. Set timeout is there, set interval is there, fetch is there, file read is there, streams are there. What else is there? Set immediate, process next tick. There are different types of asynchronous operations are there. Each operation have different priorities, right? In this case, you could see that by the output, promise as over more priority than the set timeout, right? Right. So basically, um, what the so ideally, if according to our previous understanding, what should happen is like promise, okay, promise result comes in, it will also push to the callback queue, right? And so we have set timeout B to the in the callback queue, and promise also in the same callback queue. So according to what is the nature of queue, it's like stack is LIFO and queue is FIFO, right? First in, first out. So according to that, set timeout has to come first, and then it has to return the promise one, right? But the thing is, these different asynchronous function have different priorities. So but the thing is, FIFO queue will not return anything, it will always first in, first out thing. So because of that, what we have is we don't just have one single callback queue. We also have a slightly high priority queue called micro task queue. So it's not just one queue, it's not always callback queue. So for certain function, promise is one thing, and there is if you guys are familiar with Node.js, there is something called process.nextTick, and also in DOM API there is something called mutation observer. All these things, these kind of asynchronous functions are a little more higher priority than regular asynchronous functions, right? So because of this, these asynchronous functions callbacks will not be put inside callback queue. Instead, there is another high priority queue called microtask queue. So this queue, this particular function will be moved to that microtask queue and not to callback queue, right? And again, the cursor comes into console log D, and it prints console log D, which is a synchronous function. And then when it comes to, as you can see, we have one callback in the callback queue and one callback function in the microtask queue. So always here the priority will be given to microtask queue. So if there is something in my microtask queue, callback queue will not be executed. It will always free up the thing is, JavaScript first all event loop always checks for the call stack. It will wait until the call stack is free. After call stack is free, then it will give the priority to microtask queue. So if there is nothing in microtask queue as well as in callback call stack, then only it gives the priority to callback queue. That's actually the order of execution. So yeah, again, as you can see, the microtask queue function will come here. It will print C, and then callback queue will get its own one. I mean, callback queue will get the chance. It will send its callback, which is printing log B, and this is how it got printed. Hope that make sense to you all, right? Again, I have to just reshare the screen for the next one. Let me reshare. Give me a good thumbs up if you guys can see this code editor. Yes, cool. Okay, hope that makes sense. So we have not just one queue, we have a high priority queue called microtask queue. So let me make it a little more harder this time. Okay, I will give you guys like 20. Just think about microtask queue, callback queue in your mind, and I will give you 20 seconds. You guys can type your answers. just go with what you know. Think about microtask queue and callback queue. Okay, A, G, C, E, D, E, D, B, F. A, G, F, C, D, E, B. Okay. All right, let's check the answers. Node, JS. Anyone who guessed this one? All right, let's see. Okay, this is actually the output, right? But let's execute once again. Okay, okay. So there are two problems in this. First of all, um, if you see these two different executions, I have executed this 4 times, right? So 3 times it returns the same output. But at the very bottom, you can see, I mean, A, G, C, E, D, up to that, it's always same. But at the very bottom, B and F, and in a separate execution, it returns F and B. If you run it again, B and F, B and F, B and F, now it okay, F and B. So it's not that consistent, right? Sometimes it's B and F, and another time it's F and B. But here, okay, let me go to the first execution itself. Here there are two problems. Okay, let's guess. Okay, console log A, that's obvious because like it's a synchronous statement that comes first. A print getting printed. Okay, set timeout will not be printed immediately. Process next tick will not be printed immediately. Promise resolve, no. Process next tick, no. Set immediate, no. Okay, this is another synchronous function. So G, A and G, quite obvious. That's fine. And then among these asynchronous things, so we have set timeout, process next tick, promise, set immediate, right? So obviously set timeout is a regular callback function, whereas process next tick and promise belongs to microtask queue, right? So process next tick comes in first. Okay, it print C. That's okay, makes sense. And then we have promise resolve and process next tick. But the thing is, ideally it should have go for D, right? But instead it has went to E, right? And then only it picked up D. Okay, that's the first question. Why not D and why E over D, right? Because obviously we have microtask queue, so this will be pushed first, this will be pushed second, this will be pushed third, right? Yes, but the thing is, it has if it is FIFO queue, it has to serve first in first out, right? So it should be CDE, but why CED? That's the first question. Second question is the weird behavior of F and B getting interchanged. That means like set timeout and set immediate are not coming very. I mean, the output is not consistent enough, right? Not consistent. Let's see about these behaviors. Okay. Can you guys see the screen? Can you guys see the presentation? Okay, okay, good. Yeah. All right. Yes. So as far as what we know so far, we have call stack. We have two queues. One is callback queue and the other one is microtask queue. And let's see. Let's start with the execution. So obviously, global execution context will be pushed to the stack. It will print console log A. That's fine. Set timeout. Okay. Set timeout is a callback queue function, right? So it will come to callback queue. That's fine. Process next tick is a microtask queue function. I broke the suspense. It's fine. Right. Here, again, when it comes to process.nextTick, the issue that we discuss here. So promise, mutation observer, process next tick. Everything will be end up in microtask queue, right? So what is the highest, what has the highest priority over these three things? Is it promise? Is it next tick? Or is it mutation observer? Let's ignore mutation observer for now. So among promise and process next tick is always get the priority. Okay. And promise, compared to process next tick, it has the second most priority. All right. So according to that, so in order to give callback queue, I mean microtask queue is higher priority than the callback queue, right? So uh, in order to have that prioritization, what we did, we actually add two separate queues, right? So here also we have to give process next tick more priority than promise. For that, what we do? Obviously, we have a new queue. So it's not just one microtask queue. We have two microtask queue, maybe even three for mutation observer or any other type of microtask related asynchronous operation. Also, we can have a separate queue. So that's the trick. So here, there is not just one microtask queue, but instead there are two microtask queue. So this process next tick will end up in the microtask queue belongs to next tick, and it goes to promise resolve, and this callback will end up in the microtask queue for promises. So this will also goes to this and set immediate. Again, similar to microtask queue, because like for each type of microtask operation, we have separate queue, right? It's kind of the same for regular callback queue also, because if you take, we have timer operation like set timeout, set interval. These are like timer operations, right? And if you take reading a file, network calls like fetch or streams, these are IO calls, IO operations, right? And also set immediate, it's something called a check operation, right? And also like when there is another operation called close, which is like when you're closing a file or a network request or a stream. So there is an event called close event. So for that also, that's also a different type of asynchronous operation. So for all these different type of operation, we have different queues. Okay. So for set immediate, we have a different queue called check queue. Whereas for timer related things like set timeout and so on, we have this timer queue. Okay, we have timer queue, we have something called IO queue, we have something called check queue, close callback queue, and poll queue. So altogether, I think as far as I know, there are 5 queues, maybe more. I'm not sure, but the thing is like we have different queues for different operation, asynchronous operations. That's how we ensure the priority of it. That's how event loop decide what to execute next. All right. So obviously, set immediate will also move to its check queue, and then we have console log G, which is a synchronous operation, so it does print immediately. And now we have done with all the synchronous operations, so our call stack is empty. Now it's time for the asynchronous operations. So in asynchronous operations, obviously microtask queues will get the high priority, and among that, next tick function will get the most priority. So as you can see, first it will print the whatever comes first, which is C, and then it prints what? The next tick operation, which is E, right? And then it goes and picks up the only remaining microtask queue related item, which is promise. It prints it. So far, all fine, right? I think this is the output that we got, A, G, C, E, D. So that problem solved. Now comes the next question, which is like why timer and set immediate has a weird behavior or non-consistent output, right? Because the thing is like if it is something to do with priority, it has to always return the same output, right? But in this case, sometimes it's B and F, sometimes it's F and B, right? So it's not about the priority, but there's a different problem. But according to the priority, if priority comes here, so it's always, there are different, as I mentioned earlier slightly, event loop has different phases. Okay, there is timer phase, there is polling phase, there is check phase. Likewise, there is a slide for that, which I will cover, show you in a bit. But on each phase, it will actually take whatever the callback function in relevant queue. If it is IO, it will check the IO queue whether there is something. it executes. If it is a timer, it will execute that. So according to that priority, in the circle priority, it's always timer first. Not always, but generally it's timer first. So ideally it should have been like B, and it should be then only it should be check phase, because timer phase comes before the check phase. All right. Okay, now let's come to the code again, because okay, graphical representation wise, visually this is what happened, but still we haven't answered the question of this weird behavior, right? So for that, let me share the code again. So here I have a separate function. Okay, let me open another file. Okay, as you can see here, right, it's actually the same function, a b c d e, and it's actually the same, but here I have a very expensive synchronous operation or blocking operation, because this is synchronous, so it will block. That's why people say don't write. I mean, that's why when you ask for advantages and disadvantages of Node.js, people generally say Node.js is good for I/O and not good for compute intensive programs. Why? Because it's single threaded. It always blocks the main thread, right? So if something blocks the main thread, even these timeouts and promises, everything is resolved and there in the queue, it will never be executed, because uh, this is actually blocking the things, right? That's why we should not or never write really high computationally intensive operation in your main thread, or in your main thread, right? All right. So again, here I have intentionally put this just to show you again back to the old problem, the weird behavior. Now let's run this. Okay, it is now BNF, right? Let's run it again. BNF, BNF, BNF. Now it's much more consistent, right? According to, I mean, visually what we saw is actually kind of the same, right? Visually what we saw is like B first and then F. Now, if you check this code, here it has this inconsistent behavior, whereas here it has really consistent behavior, which is always B and F. So what this blocking code did. So this is where we have to dive a little bit into the internals. We are not going to dive that deep. But the thing is, um, we already discussed like set timeout is actually using a timer API, right? In the web API, so in Node context Node API. So there is an implementation for this set timeout internally for the timer API. So the timer API does have its own elapsed time. So I think it's around 1 millisecond. So generally, it will not. It even though it's zero, it's not always zero. It's like nearly 1 millisecond late, right? So just visualize a circle. Just visualize event loop as a circle. So it will come to timer phase here, right? Um, yeah, I will show it in a bit, but anyway, so it will always start with timer phase. But if in the timer phase, if the elapsed time is not over yet, if that means like we have an internal timer API that hasn't been initiated yet, that means in the first loop, in the event loop, in the first iteration, the timer phase might not have anything in the callback queue, relevant callback queue. But on the check phase, it might have, right? Because it depends on the elapsed time. So here, what happens here is, so code will execute, everything will be put there. This one will take much more than 1 millisecond, maybe like 10 mil. It's nearly 1 second. It took 1 second. 1 second is quite enough for the backend timer API to finish its job and put the relevant callback to the callback queue. That means, um, okay, let me reshare it again. Yeah, if you go to this picture, hope you guys can see the presentation, right? Yeah. So if you guys can see this picture, so set timeout will initially will be in the Node API, and then it will end up in the timer queue, right? So when having a very expensive synchronous operation, that will keep this call stack busy. So event loop will never consider these things. So that delay is enough for timer API to send whatever to its timer queue, right? So when it's done with its synchronous operations after the loop, after the for loop, it will actually go in the order. That's why timer API always came first, okay, in a more consistent way, right? So yeah, I think that is all about that particular problem. That's why with a very expensive blocking code, it has managed to be much more consistent, I would say. Okay, so basically this is the different phases that I talked about a little while ago. So when it comes to this is specifically for Node.js. So when it comes to event loop, it will always have these different phases. And also we have this micro task queue. So before, even if it is in timer phase, it initially always check the micro task queue first, and then only it consider its items in the queue. Okay, same for pending callback. Pending callback is for like finished callbacks, but not considered in the previous iteration. Those will be end up in pending callback state. So these are the different phases. So timer phase is for set timeout and set interval. Pending callback is generally for IO operations, because like there is something called poll, right? There's a phase called poll. In the poll phase, what JavaScript does is it actually calls all the IO operations, whether it's file read, network request. It actually polls everything and put the items to the queues, right? So in the pending callback state, what it will do is it will whatever it grabs in the poll queue, it will be executed in all the deferred IO operations will be executed in the pending callbacks. Idle and prepare is not something related to exactly in sync with a queue. Idle and prepare is something for event loop. Like this is where it actually kind of like, okay, this in this iteration I have to perform these actions. It's something for its internal purposes. Poll is obviously IO operations happens here. It will poll the content and put the callbacks to the queue. Check phase is for set immediate, and close callback is obviously for like um, the closed operation. Okay, anything closed operation. All right. Yeah, I think I just like to finish things up with uh, another code snippet, which you guys can guess. Okay, let's see. We'll give you like 20 seconds. Just guess the output. Just think about microtask queue, callback queue, different microtask queue, different priorities, and so on. This is not very straightforward also, but yeah, but still. F, okay, CB. Okay, let's run it and see if your answers are like this. But still, it's kind of a tricky one, so it's fine. The thing is, let's see, let's try to understand that. So obviously we have console log A, right? And this is F. Yeah, just see. Yeah, okay, my bad. Sorry. I'm just wondering like why it's printing like this. It should be 7.js. Yeah, cool. So as you can see, obviously it will print A first and F second because these are like synchronous operations. And then set timeout as it's a asynchronous operation. Promise asynchronous, process next tick asynchronous. And also because of this block code, we will have consistent behavior, right? But doesn't, okay. Let's see. We have among this process next ticks always get the priority. So it prints E third. And then we have promise resolve and set timeout. So promise resolve obviously have the higher priority. So it prints D and then it has a set timeout. So set timeout will be pushed to the timer API. So it will not be executed immediately, even though if it is coming under promise fallback, it will not be executed immediately. It will be allocated for the next iteration. So it will be pushed to the timer queue, but already we have things in the timer queue, right? So it will print B, and here we have a promised resolve. So now what we have now is like obviously it will when it picks up set timeout, it will immediately print B, and we have a promised resolve as well as a set timeout. Among this, as I mentioned before, in each phase it always check the micro task queue first. So that's why C got priority over G, right? Uh, yeah, I think if you guys got the understanding of this, I think it was um, really good. So yeah, so finally what I like to show you is like when you talk about event loop, um, it's when you talk about event loop, it's just not always like one queue. It will have several queues. Okay, so it's not just always. I mean, these are the different components. Event loop is not the entire JavaScript runtime, but it has different components, and also in each component, it will have its own priorities. Um, yes, I think that's pretty much it from my end. Um, Give me a second, guys. I'm having, yeah. Yes, so that's it, pretty much it from my end. So if you guys have any question, just put it in the chat. I can actually try to answer. Yes.
Thank you, Charles. If anybody does have any questions, please just pop them in the chat. Don't be shy. I didn't get any of those questions right, Charles, so I have no questions. Okay, so I think we have a question here. Is Node.js, is it always single-threaded?
Um, it's quite debatable. I think it's not. At least as of now, it's not. As a language, JavaScript is definitely like as a language, JavaScript is definitely like single thread, but it does have support for when it comes to browsers. We have something called web workers, which is a kind of alternative to have different threads. And in the node side, we have worker threads. But other than that, other than these worker threads and web workers, internally we can't really be sure whether node always single threaded, because for example if you're using crypto, there is a module called crypto in node.js, right? So when it comes to this crypto module, it internally because node.js or even the browser's version of JavaScript runtime, everything is built on C++, which does support threads, right? So when it comes to this kind of crypto kind of model, which is compute intensive, internally it will use multiple threads, right? So as a language, for us, we will not use multiple thread. Of course, now web worker threads are there, but other than that, JavaScript internally also sometimes use threads depending on the use case.
Okay, we've got another one here from Manuba. How viable would be the use of worker threads?
Um, I think it's the thing is the issue with race condition threats is always the race condition. So it's the way that we kind of have to deal with those. So uh, personally, I haven't used worker threads that much. I have used web workers, which is it's not as same as other Java-like language threads. It's more of a message passing way of handling things. So uh, yeah, I mean, it depends. I mean, it has to be the. I mean, if we are taking care of the race condition in our mind, should be possible to use worker threads also.
Cool. I've got another question here from Suraj. Is there any limit on how many callbacks we can execute in an event loop cycle?
Uh, it's also kind of like the thing is like little while ago I mentioned about event loop. You are sorry, JavaScript using multiple threads, right? So there is a configuration where which we can tune to set those values. But this is something internal. Even we don't have any visibility to in a higher level. We don't have any visibility on how many callbacks in each iteration the event loop can execute. It's not something that we can configure or even we can see. What we can see is at most we can see like how many things are there in the callback queue we can see, but what is the range, how many callbacks it can support, it's not something that we can configure or see it anywhere. So it's something internal. Maybe we have to go through the node implementation C++ code and to understand. But the thing is like uh, it kind of handles in its own way. It's really rare that it's running out of callbacks and so on. But if we have such scenarios, it event loop handles it accordingly, because for each phase, it can actually take number of callbacks, executes. If it is too much, then the allowed number of callbacks, it will just jump into the next lock. In technical term, we call this starvation. Starvation in the sense, let's say there is a lot of timer queue things, timer queue callbacks are there. Because of that, IO callback will never be executed, right? So this is what we call starvation. So um, so when it is running out of when it reaches certain limit, it will automatically switch to the different phase and try to grab those things in order to avoid starvation. So it's something that Node.js handles internally, nothing that visible to us. We can't get that range. uh, I think event loop is kind of a common thing. Only thing is like as a Java front-end engineer, there are certain additional things you might need to be aware of, such as how event loop works with DOM manipulation, mutation observers, and so on. The thing is, it's more or less the same. The conceptually, the idea is same. Microtask queues and everything is same. So even for the browser, it's always the same, except yeah, they don't have things like set immediate. They have set immediate, but not recommended to use. But there are here I have shown certain things which are specific to Node, but there are different things specific to front end. But more or less, even though you don't have to understand every internals of Node.js, because I haven't covered the internals also, because there is something if we had to talk about event loop internals, there are things like libuv, how it is used, and so on. It's always good for the knowledge, but for a front ender, is it required? Maybe no. For your day-to-day work, maybe not. But um, but anyway, knowing the understanding of event loop is always good, because like other than certain implementation details, both event loop works both same for the browsers as well as in Node runtime. Uh, yeah, I hope that answers your question.
I've got one here from Nadun. What is your recommendation to beginners who'd like to dive into coding like this, please, from your experience?
Uh, I think it's just the the thing is like it's always, I mean, you have to start somewhere. So if you don't understand something, maybe you can go internal. But now We have tools like ChatGPT also, where you can actually, it's not always accurate, but you can get some idea out of it also. But the thing is, like, if what I did in my experience is like, um, uh, I subscribe to certain resource forums and YouTube channels. Especially if you want to dive deep into Node.js, there are really good conference talks available in Node.js own YouTube channel. So things like whether Node.js is single-threaded or multi-threaded, event loop, but there are lots of very in-depth discussions in YouTube channel in their own channel, so you can refer them. And also, like, there are like quite good YouTubers also, like Namaste JavaScript is one thing that really useful. So there are many other YouTube videos also, because I'm a YouTube person, so I seek for most of the knowledge from YouTube. So other than that, there are like you can refer the documentation, which is sometimes very complicated, especially Node.js documentation is hell complicated. So what you can do is, like, you can get the help of ChatGPT along with um, yeah, exactly. That video is really good. So ChatGPT, as well as your Node documentation. If you don't understand something, just check with ChatGPT. That way also you can actually understand. So there are plenty of conference talks, and also like there are resources out there. It's like, just if you get a question, just do some research. Probably it would help. That's how I learned. Yeah, it works sometimes. Yeah.
I think we have time for one last question, which is any recommended books to understand deep concepts in JavaScript?
Okay. I guess, as I mentioned before, I'm not a book person. I'm a YouTube person. So there are really good books out there. Um, I think there is one from there is a guy called Coddam. His YouTube channel is Coddam. So he written a book which is quite good. And also, like, I can share some of the books. I don't really recall all the things, but like I mentioned before, I'm more of a YouTube person. So, but there are really good books out there. Probably I can actually just send something with, maybe with the slides when we share. I can add some resources to them.
Amazing. Do we have any more questions from the audience? I think we might be done. Thank you so much, Charles, for taking time out. Go and have some lunch now, I guess. And thank you to everyone for joining us. This whole presentation has been recorded, so it will be available on YouTube next week on our YouTube channel. Please go and follow us, and have a great day.
Thank you guys for listening. Thanks for the opportunity, Lulu. See you guys in a different talk.
See you, Charles.